So bits and bytes, ints, and everything else. So you have your RAM, and these chips are basically like an array in Excel of bytes. It has little, each one of these rows that I've highlighted is a byte long, right? And there's how many, you might say? Well, this is a 1 gigabyte chip. This entire thing is 1 gig, so it's like 10 to the 9 bytes. There's from address 0 to address 1 billion, or whatever that is, 0 billion. Just like represented in this Excel chart. So whenever you load, whenever you turn on your computer, your programs go from the hard drive. The first one that goes is going to be, the operating system. It's going to fit in the first addressable bytes, right? So at the very 0 from here to here, it's all your operating system stuff. And then, your program, your C# program, is going to also take some space. So now that your operating system is loaded, it's going to take care of, when you click this, to allocate space where it's going to run. So where it's going to be somewhere on the RAM, somewhere in here. This little bit is going to control where your program is going to go. It might be from here to there, let's say. And if it is there, it is address from address X to address Z. It's going to be somewhere here, from address X here to address Z. It's going to highlight it. It's going to write the actual code that you wrote, of course converted, and it's going to say, all right, from here to here, this is your code that the actual text of the code, and from here to here, inside these are going to be free cells, and from here to here, it's going to be your executables. So whatever you write here will be loaded on runtime into these bytes. Let's see how bits and bytes work first before anything else. So our number system is base 10, right? Because we have 10 symbols. These could have been anything. And what happens is you have your unit symbol, which is this guy. These could have been anything, right? Let's say this symbol, this, this, this. Okay, G plus sign, I didn't have a plus sign, a wiggle, and this guy. They're just symbols. All we know is there is a unit symbol, and at any symbol where you are, if you add an extra unit symbol, you get to the next one, right? To the next one and the next one, and you have cells. One cell, two cells, multiple cells. So if this cell is holding this symbol and we add 1 to it, what happens is this cell gets back to 0 and this one goes back to 1, right? We just reached a 10. I know you know this, but I'm going somewhere with this. I am going somewhere. If our system was just 5, a base 5 system, right? It would have looked something like this. If you are at symbol, let's make this a little thicker actually. I don't even know how to get this brush to be thick. Okay, this will work. So if we are at this symbol, if we're at 4 and we add 1, we get to 5. If we add 1 more, now we go to, because that's it, we only have 6. Actually, this would be a base 6, sorry. This is a base 6. We get to this symbol. It's not, I don't think we could call it 10, but whatever. And so on and so forth, and you know how it goes. And if you get to 1, 5, if you add 1 more, then this goes back to 0, and this goes to 2. Right? There are other bases where, in fact, we had to make up symbols. The base 16, the hexadecimal, has this symbol, and this symbol. So, well, we call them A, B, C, D, E, F. meaning that when you have cells, when you are at symbol that looks like this and you add a unit, you get to this symbol, and you add a unit, you get to this symbol. Keep on going. When you get to this unit, which is the last one, and you add a unit symbol, this gets back to 0, and you have 1 tens added, and so on. Now, binary, as you can imagine, is just 2 symbols. All right. I'm giving you this this run through so that later on you might want to look back at this, and it might solve some problems. Now, with binary, same thing. With our cells, if you are at this symbol and you add a unit, you are at this symbol. If you had one more, there's no more symbols available, so this rolls back to 0 and this goes to a 1. This is the equivalent of decimal number 2. You see how 0, 1, and then we don't really have a symbol for 2, so we roll back the units and we add 1, so 1, 0 is 2. Now these cells are bits, right? A byte is 1 of these, and this is how everything is going to tie together now, because a byte is 1 of the 8 of those right here. This is exactly what a byte looks like in RAM. It's just a space that can hold 8 cells, and each can be a 0 or a 1. And so how many combinations of those? Oh, so of course, how many combinations can you make with our 10 digits, right? If you have a given amount of space, if you have one cell, you can only put 10 different numbers, from 0 all the way down to 9, right? That's all the digits we can write. So one cell gives you 10 digits. 2 cells can go from 0, 0, and a maximum of 9, 9. That's 100, right? And 3 cells is 1,000. Okay? Coincidentally, the number of cells is 10 to the power of those cells. So 10 to 1 cell is 10. 10 to 2 cells is 200. 10 to 3 cells is 10 to 2 cells is 100. 10 to 3 cells is 1,000. Same thing here, except that the base is no longer 10. This was the base. The base is now 2. So let's just keep everything on the same screen so you can see everything. So out of one cell, what's the maximum amount of digits we can make? We can make a 0, we can make a 1, or a 1, that's all it can hold. That's 2. If we had 2 cells, it can go from 0, 0 to 1, 1. Well, how many is that? Well, let's say 0, 0, that's 1. 0, 1, that's another one. 1, 0, that's another one. 1, 1, that's another one. And that's 4. 3 cells is going to be 8. And just like I said with the bases here, this is 2 to 1 cell, this is 2 to 2 cells, this is 2 to 3 cells. So a byte is 8 cells, 1, 2, 3, like I said here, so it's 2 to the 8, and the maximum combinations that you could do with that, I think, is 655, is, 255. To the 8 is 255. That means with 8 cells, that range from 0, 0, 0, 0 all the way across to all the permutations, all the combinations, to this should be 255. Alright, so now that we know a little bit about these bits and bytes, what happens? You have to know that an integer is 2 bytes. So when you run this program, when you click the start button, your program will we'll get to here. It's going to read line by line. It's going to get to here. It's going to say int. All right, I must reserve 2 somewhere that is free. Not here. I can't reserve these 2. I can't reserve these 2, but I can reserve these 2. Right. It's going to say these are reserved. It's going to say, okay, this is X, so it's going to put, I did that already before. Little letter X, little letter, and put the equivalent of 8 in binary, which is 1000. It's going to fill all these with zeros, except for this one to 1, and that's how your data is going to look. A character is only 1 byte, so it's only going to take 1 byte, color it, sorry, reserve it, give it a little tag C, it knows that it's a character, and put the letter A, capital A. Now what is capital A, you might say? How do you represent capital A in binary? You can just look at car2 ASCII, no, it's the ASCII chart. This is pretty good. Okay, so there we go. Capital A is number 65 in decimal. So if you convert that to binary, what is 65? Well, I know that 64 is a power of 2,